All right, so we're going to do the last lesson on thermochemistry. So if you haven't noticed, thermochemistry has just been kind of crazy. It's been basically everything we've done all year, just with heat added to everything. And then this new graph thing, the heat with the heating curve. It's just kind of a very broad sense of just topics. And so today is not different. This is going to be something completely new to you, something we haven't done at all. So this is a whole new topic on its own. So what we're doing today is Hess's law, and Hess's law requires you to add, multiply, divide, or reverse chemical equations. And yes, we are doing all of four of those things to chemical equations. So yes, you heard that right. And we're going to calculate the enthalpy changes for when we manipulate these equations. We're also manipulating enthalpy changes. So yeah, we're going to be calculating how much heat or energy changes occur when we do all of this to a chemical equation. So Hess's law, this looks like a really good multiple choice or matching question, but it says that if you add two or more chemical equations, you get an overall equation. Then you can also add heat changes to get the overall heat change. So basically, we're going to manipulate some equations, and there are rules we have to follow to determine the heat changes in all of this. So how to add chemical equations. So basically, and remember a chemical equation is like a substance plus a substance will yield another substance. So to add those, we're going to be looking at the coefficients, and we'll look at coefficients, and then we'll also look at the actual chemical that we're adding or subtracting. If there's the same chemical on either sides of the arrow, they're going to cancel out. So there's a lot of rules to remember on this assessment that's coming up. And if two identical substances are on the same side of the arrow, you're going to add the coefficients together. So if they're on opposite sides of the arrow, they're going to cancel, and if they're on the same side of the arrow, you're going to add them. And then you're going to keep substances on the same side of the arrow in the final equation. So you're not going to just kind of switch substances as you feel needed. You have to keep them on the same side of the arrow. Unless you're reversing, then there's rules for that. So for an example to add equations. So adding equations, remember if you see something on one side of the arrow, you can cancel it on the other. So for example, you have CO2 on the right side or the product side of the yield sign, and you have CO2 on the left side. So those are going to cancel, okay? And yes, I forgot to mention, but I always mention to you, make sure you align the arrows. That way you don't get confused. That way you don't think that one is on the other side when really it's on the same side. So we're going to cancel these carbon dioxides out because they're on the opposite sides of each arrow, so they will cancel. And then you have this oxygen here and here. However, you have this weird half sign, and you'll see all kinds of fractions as coefficients, even though I told you that's bad, but in this case, it's okay. But we have half of an oxygen molecule, so it does need to cancel out half of this oxygen. So we will need to cancel out the half. That means it only leaves a half here. And then we're just going to add everything. So this carbon will come down here, plus half of an oxygen, and then the yield sign, and the only thing that's left on the right side is this carbon monoxide. So that would be your equation, the new chemical equation once you've added these two together. All right, so we're going to add these two equations. So we have copper and copper, but it's on the same side of the equation. So since they're not on opposite sides, if they were on opposite sides, we'd cancel them out, but they're not. They're on the same side, so we're going to add them. So we add the coefficients up. So this will be 6Cu, okay? And remember, this coefficient and this coefficient are 1, so this will be 2 oxygen molecules, O2s. And then here, these two are not the same, okay? This is copper oxide, and this is copper 2 oxide, okay? So these are different molecules, so you will need to do 2 of these plus 2 of these on the other side. So you're going to have a chemical equation that looks like this. So you'll just bring everything down. In this case, nothing canceled, okay? So you just add them. So how to reverse chemical equations. So one of the rules to reversing chemical equations is that basically whatever's on the left side will go on the right, and whatever's on the right side will go on the left. And then the main thing you have to remember, do not forget to change the sign of the delta H, the change in heat, okay? If it's positive, change it to negative. If it's negative, change to positive. Okay, so it's asking us for an example, reverse this reaction. So we have 2 phosphorus on this side, 3 chlorine molecules, and then we have this right here, and our heat, okay? So basically everything on the left side of the arrow, or the reactant side, will now become on the product side and vice versa. And then the only thing you need to make sure you don't forget is to change the sign on your heat. Okay, so switch sides, and that's easy, right? That's no big deal. And then with the delta H, you're going to change the sign. And that's how you reverse reactions. How to multiply and divide chemical equations, okay? So to multiply or divide, you're going to basically take the coefficients and either multiply or divide by the number the question's asking for. So if it says multiply this equation by 2, you just take all coefficients and multiply it by 2. And don't forget to multiply or divide the delta H by whatever number the question's asking. So these are just rules to multiplying and dividing. Let's do this example for multiplication, and then I'll kind of overview it, sorry. So it says multiply this equation by 2. So basically you're going to take this whole equation and multiply it by 2. That's easy. And you're only multiplying the coefficients. One mistake you can make is thinking, okay, I gotta multiply this by 2 and this by 2 and this by 2 and this by 2, and you don't. Only coefficients. So then you have 2 calciums, 4 carbons, and so on, okay? And then you just take the delta H, multiply it by 2, and that's it, okay? So as far as combining rearrangements, so what we're doing now, so this is kind of an overview. So those are the rules for adding, subtracting, multiplying, dividing, rearranging, reversing, or whatever. Those were some of the rules. Now, it's not going to be as easy as reverse this equation, right? They're going to give you an equation, and you have to manipulate the stuff that they give you based on what they give you and based on the rules that you need to follow when you're adding, multiplying, and dividing. So obviously, I'm going to show you some answers here in a second. But here are combining. So you will be combining these rules in the actual problems. You won't just be asked to add these two together. That's too easy, right? So we're going to reverse and multiply by 3. So basically, this will be like one of the problems. You're going to reverse it, right? So all of this stuff will go on the product side, and the iron oxide will go on the reactant side. But then we also have to multiply by 3. So we're going to switch sides and multiply by 3, and that will be our answer. Okay, so you will have some fractions in here, so remember your fraction multiplication rules. They're pretty simple. This is something that my kids learn in 3rd grade, I think, so I think you can handle it. But make sure whatever you do over here, you don't forget to do here. So then you also have to change the sign and multiply by 3, and that would be your new delta H. All right, so here's what the questions will look like on your test regarding Hess's law. So it'll say, this will be everything you're given on the test. So it'll say, find the delta H for this equation. So, and then it's going to say using the following information. So we have 2 equations and enthalpies here, okay? But we only have 1 equation here with no enthalpy. So we're trying to find the enthalpy for this. But what we're going to do is we're going to manipulate these equations, okay, to where once we add them, they're going to look like this equation, okay? So one hint that I always tell my students is that you pick one substance that appears only in the overall equation. So for example, C2H4, okay? So you don't see carbon, you do see hydrogen, but you see it in both, so it's not going to be very helpful. So you see C2H4, okay, and you see it here. So obviously this equation we're going to have to reverse, okay? So you see those two, so we're going to have to reverse it. So that means this, let's see, yeah, it goes down. So this is reversing the equation. That's pretty easy. Just you take everything here, put it over here, take this, put it over here. But don't forget to do the same thing over here. So we would just reverse the sign and you would have a negative 52 kilojoules. Now we need to do this equation as well. Okay, so again, we do have hydrogen here, but it's not going to be very helpful to us. Look at this right here, C2H6, it's also over here. So C2H6 is good. So you don't need to do anything to it. It's on the right side. It has the proper coefficient. Everything is good. So we're going to keep this equation the same, okay? And that means we keep the energy the same. And then we're just going to add these two together, and we should get what's up here, okay? So keep in mind that if you're adding equations, okay, if it's on the opposite side, so this chemical and this chemical is on the opposite sides of the arrows, so they're going to cancel out, okay? So is the carbon. Now, the H2s don't completely cancel out, right? Two hydrogens will be canceled from here, but we'll be left with just one, okay? So then the overall equation will be C2H4, because nothing canceled it, plus 1 H2, okay? And then on the other side of the arrow is this. Everything else has canceled out. And then since we're adding, you're going to add negative 85 plus negative 52, and that's our new enthalpy, and that's our actual answer. So I know this is kind of all new to you. This is something we have not done before. We have not manipulated equations at all, or heats. So this is kind of new. This will take practice. This will look just like on your test, as far as you'll be given an overall equation and then some equations to manipulate to the point where they need to equal what's up there. And then you find the heat. So let's do one more equation just to kind of maybe cement it or get your head around it a little bit, or at least you to the point where you can ask me questions in class. So find the delta H for this equation, okay? So we don't have our change in enthalpy here, but we're going to look at these two equations and manipulate them and their heats until they become this equation once we're added. So again, I like to look at something that's unique to the equation. So hydrogen, no. Chlorine, yes, but we're not going to look at that because we could. But you could have looked at chlorine and said, okay, if you multiply chlorine by 6, it'll be the same here. You could have done that. But I like to find something a little less fractiony, I guess. But you could do it. Hydrochloric acid is here, and it's also here. So it's on the same side of the arrow, so we're not reversing it. However, there's 6 of them. So we do need to multiply this whole equation by 6. So that's what we're going to do. So we multiply the whole equation by 6 plus its enthalpy, okay? So don't forget, we need to multiply this by 6. And then here, we could look at nitrogen, okay, and we could say, okay, we need to multiply that by 2. We could, but I like to stay away from fractions. You don't have to, you can do it. But I'm looking at NH3, okay, so NH3 is on this side, and so we're going to have to reverse it, right? So we're going to reverse this equation, but it has a coefficient of 2, so we will have to multiply it by 2 as well, okay? So we will reverse it and multiply it by 2. We have to do the same thing to, let me put that there. We have to do the same thing to its heat, its delta H. So we're going to have to reverse it, which means make this a positive 46, and then multiply it by 2. Okay. Now we need to add these two equations, okay? So when you're adding, okay, remember those rules. If you have 2 of the same chemical on each side of the arrow, they're going to cancel. So the H2s will cancel, and they're going to completely cancel each other this time because the coefficients are the same. So yes, those will cancel. Let's see if anything else will cancel. Nothing else will cancel, so we're just going to add all 4 of those, okay? And we have our equation. So we will have our new equation, and then we need to add our heats, okay? This is the main thing because it's asking for the delta H. This is more for checking our answer to make sure we've done everything right to match this. So we just add these 2 together, and that's what we get, and that's our answer.
All right, let's do number 3 of our homework. Determine the delta H for the reaction, for this reaction, and we're going to use this information. So we are going to basically first see what we're going to do to these equations. So we have NO. For sure we need to reverse it. Okay, so we're going to have to reverse it. And the coefficients are matching, so we're going to leave that alone. So we're just going to reverse this, which means we need to change the sign. So we're going to have NO will yield 1/2 N2 plus 1/2 O2. All right, so we're going to look at NO2. Okay, so there's NO2. I like to look at the similarities between each one. So here I found this one. I tend to stay away from, fractions. I just pick one that's very unique to the whole reaction, and one that's not on in both of them. If there's one in both of them, it can kind of be confusing as to, okay, the oxygen, if I looked at that, it would have been, how come you would have reversed it looking at this? So for 1, I stay away from fractions if I can, and for 2, it needs to be unique to the one equation I'm looking at. So there is no NO over here, okay? There is an NO2, but not NO. There is an oxygen molecule, so I kind of, you don't want to look at something that they both have in common. Otherwise, you might think, okay, I don't need to do anything to this because it's have 1/2 oxygen on the same side and we're good. So make sure you choose something that the other equation doesn't have to look at to do your manipulations. So here's our new equation, and then it's negative 90.0 kilojoules. All right, so the next equation we're going to look at is this one. So this one's the unique one, right? Because they both have N2 and O2. So here we don't actually need to do anything with coefficients, and we also don't need to do anything with as far as reversing our equation. So we're good. So we're going to leave it here. So I like to keep your arrows aligned, right? Okay, and we didn't do anything here. Now we're just going to add. So we need to just, we do this to check to make sure we haven't messed up. And then if we haven't messed up, then we're going to add these 2 together. So basically nothing on each of these sides is going to cancel. However, we have oxygen on this side. We have 1 1/2. So the 1/2 is going to cancel this, and it's going to be a 1/2, okay? And then we have a 1/2 nitrogen, 1/2 nitrogen, so they're actually going to both cancel completely. So we're left with NO on this side and 1/2 of an oxygen on this side. And that's going to yield, canceled, it's going to yield only NO2. Okay, so then all we have to do is take the difference of these, and we're done. So negative 90 plus 34, and that will be negative 56. So the delta H would be negative 56.0 kilojoules. And that's our answer.